What's up, guys, and welcome back to another quick tip. So this one is pretty much sparked in response to a little back and forth I had with Double Motion Design, which is another awesome Cinema 4D YouTube channel, where they were experimenting with some particles moving across a mesh. And I pointed them to my tutorial because I had just done a tutorial about particles moving across a mesh. And so we had kind of a little back and forth just talking about some different stuff. And one of the things that was mentioned was that the setup that I showed last time is good for a static mesh, but not so good for a mesh that's in motion, which is true. And it made me realize in my last tutorial, because I wanted it to be quick, there are some details that I sort of like glossed over, didn't really go too deep on in how I had that set up. So I want to talk about those things for the previous setup, but then I want to talk also about a completely different setup that is specifically made for particles moving across a animated surface, because the reality is that that previous setup wasn't actually made for uh, a animated mesh, and it's probably like a better way to set up particles flowing across an animated mesh, and so I'm going to also show that. But I also want to talk a little bit about the previous setup and give a few details about how you can improve that and also sort of like make that work a little bit better. So going back to this previous setup, one thing that I didn't really mention that's making this kind of work, I think I mentioned it very quickly, but I didn't really go into it, is in this setup, there are lots of particles that are getting killed off, that are freezing. And the way that this is working, like none of these particles are actually stuck to the surface. And if I turn off the part of this sim that's dynamically killing off particles, what you'll see is that we have a bunch of particles that eventually just kind of become static. So the reason that that's happening is especially with the, let's actually turn that off again and then turn off the, there's a random field in here. Is it, or was there a turbulence? I think it's this random field. Yeah, there we go. Okay, so the random field is basically creating sort of a, wait, is this the right one? Yeah, okay, so you are controlling the turbulence, partially some of this turbulence. Anyway, what we end up with is a bunch of these particles that are getting frozen in here. And it has to do with the turbulence basically kind of like finding these pockets of equilibrium, and then the particles aren't having any forces acted upon them. They all have a limited lifespan also in here, so they're just sort of like dying off eventually. But yeah, we've got a bunch of static particles that aren't doing anything. That kind of makes the whole thing look a bit less interesting. So one way that you can deal with that is in the volume builder. If you go to your model, you have this exterior voxel range and this interior voxel range. And you can think of these as basically like the points are sort of like starting on the surface, but then there's kind of like a buffer that goes out from the surface and a buffer that goes sort of like into the surface. And so if you start to increase that, it's basically like you can see that it's kind of like you're fattening up the model. If we just visualize it, you can see that things are just getting sort of like bigger. So that's one way to sort of start to deal with particles escaping essentially the influence of this velocity field. But you'll start to lose the details of the actual model, which in my case, I wouldn't want that. And I think in a lot of cases, you might not want that. So the way that I'm actually handling this is that I'm just killing all these particles, all the particles that are static just die. And this effect kind of works and looks interesting by just producing a ton of particles. Like there's so many particles that you don't really notice that some of them are, they're constantly being created and they're constantly dying. And if you just have a lot of particles, then it just looks like one, dynamic flowing sort of thing. So basically, it's a pretty simple setup. So what you can see here, hopefully you don't have a reaction to that, but basically what that condition is doing is just saying that, and let me just stop this so that it doesn't go crazy like that. Their velocity, if it's less than 1, basically if they stop moving, then kill the particle. That's it. So that's how that's set up. It's really simple. It's just like if the particles stop moving, kill the particle. And so even if we come in here and let me just give this some more time. So even if we come in here and start to move this mesh around, rotate it or whatever, the particles, well, are you moving? There we go. The particles just immediately die. So even if you move the mesh, they're not just going to be static and just kind of like floating in the air, because as soon as they stop moving, they all just die. So it'll just, if this was animated, it would pretty much look the same, because particles are constantly being born and dying all the time already within this setup. Doing it here in the viewport, you can see this kind of like them flipping on and flipping off. But if this was animated and the particle, this is about, I did a render, you can find that on my channel of this. It's probably like 10 times more. It's like whatever I'm emitting here with another 0. So it's like 10 times more particles. If this was animated just kind of like smoothly and it was all cached, you just wouldn't, it will still just look like the particles are flowing across the surface and nothing's happening, because they're always dying and being born at a rate where the whole thing just sort of like looks cohesive. Okay, so that's a little bit more detail into that setup. Now let's jump over to this setup, which is, again, like I said, I wouldn't actually use that setup if I was trying to have particles flow across a totally animated surface like this. It's probably not the best way. It's going to be kind of slow, a little bit clumsy. And there's a node in here that's kind of, it's not the most intuitive thing, but kind of built for having these particles flow across a surface. So if you're familiar with X particles, you know that we've got the what's it called? XP follow surface. Yeah, XP follow surface, which very, very, very simply, just like a couple of nodes, you can get particles to follow across. Let's just actually delete all this just so you can see how quick and easy it is. I've got a torus. I make an emitter. I tell that emitter to emit from an object. This is the object. Emit from polygon areas. So we get something like that. Let's add trails to this so we can see it a little bit better. Boom. So that's what's happening. Take this. Let's make an XP follow surface. This is the surface I want you to follow. And now if we press play, you'll get something like that. And it's really that easy. Now you can see we got some static particles here. That's because the particles are still getting emitted along the normals of the surface. So some of them are not really having a chance to go around the surface because they're just getting emitted out and then they're just kind of freezing. Easy way to fix that is to say, let's not give these particles any speed by default, and instead give them their first initial speed through a turbulence, and there you go. So then all the particles will just follow the surface based on that. So it's very, very easy to set this up in X particles. It's a little bit less intuitive with the Cinema 4D particles, but the Cinema 4D particles do have a benefit over the X particles. So what's happening by default with the X particles follow surface is that the particles are basically like stuck to the surface, and you have to do something. You have to like create some action to get the particles to be unstuck from the surface. Within the Cinema 4D particles, the particles are not stuck to the surface. The particles are just really, really, really attracted to the surface. Um, and what that means is that you are going to have some particles escape, but similar to the last example, you can just make a condition that says, like, if the particles escape, then kill the particles. What makes that work is that within this surface attract object, there's an output that has some custom attributes that you can assign to the particles. One of them is this inside effect radius. So why this is really good is because you basically have an event that happens when the particles escape the object. The X particles follow surface doesn't have that. So if let's turn all of this off. I'll do a really, really, really quick explanation of what's going on here with this mesh. But if we turn all that off, let's make an X particles emitter. Again, object. This is the object. Emit from a polygon area in this selection. So we've got that. Just the particles being emitted from this green section. And so I am going to, right now it says the particle direction is the normal. Let's say we want to emit in the positive Z direction. So now they're just going to be emitted like that. And then we can turn our turbulence back on this plane, which is just like a cloth object. Okay, so the turbulence is affecting the plane, but it's also affecting our particles. Let's go into our particles modifiers and say, like, yeah, don't be affected by that. Okay, so now the particles should just be moving flat and the plane is deforming. So now what we want to do is, again, let's add that XP follow surface and say this is the surface. And if we press play, now these particles are going to follow the surface. What's different here is that when they get to the edge of the surface, you see they just bunch up on the edge here. And there's no like event within the follow surface modifier in X particles that is saying you're hitting the edge right now. There's like, it's just like you're just stuck to the surface. So I can't, in a sort of like action-based way, trigger any other modifiers to like kill particles, to do anything, just because the particles sort of like hit this edge, because they're like hitting this edge too. None of that really means anything. So there's some like hacky ways to kind of like deal with that. You could do it just based on, say, like the particle's lifespan, but that's not exactly that's not based on, again, like the particle just kind of hitting the edge of the actual surface. So that's a bit of a limitation there. Whereas with now let's delete all this. With the Cinema 4D particles version, let's not do this. This object is based on a radius, and so there's an effect radius for this object, and you can basically just say, okay, when the particles are outside that radius, I have a thing that I can reference to say, like, do something. So this condition is referencing, so you can see in this condition we've got a custom property, it's in range. This is also sort of like not intuitive, but I'm assuming that this is a Boolean. and it's set up, it just says equals or not equals. You set it to equals, 100% chance. And what that's going to do is that once things escape the range of this, like if we turn this off, you can see the particles are still following the surface, but then once they hit the edge, they just go off and they do their own thing. Now we could do, what's really cool about that is that, again, I'm killing the particles, but we could do all sorts of stuff. We could have the particles change group. Basically, all the different things that you can do to particles, you have a thing that you can reference now to where you can have some change happen based on the particles no longer being in the radius of this object, which is actually pretty good and a thing that, as far as I know, you can't do in X particles. So, that's one of the things that I'm trying to find as a X particles user. I've been using X particles for years and years and years now. It's my main sort of tool for professional work when I'm doing like particle stuff. The main things I'm looking for as I'm experimenting more and more and more with the defaults and with 4D particles is like, okay, what can you do that X particles can't do? Like, what are the situations where I might use these particles versus X particles because I already got X particles. I'm already paying for X particles. If I can do it in X particles, I'll probably just do it in X particles. So like, where are the cases where this is going to be something that is useful to me? So this is one. And I actually do think that this could potentially be pretty useful. Okay, so let's set this up from scratch. I've got a couple of other little quick tips in here also, like how I'm setting up this. I've got this node mesh. This is really just about having a procedural mesh that I can make a selection on. It's really simple. It's just a node mesh, which there you make a plane, you make a selection, and then you store the selection and you give it a name. Once you give it a name, it gets this tag and this tag. Again, if we jump in here, not there, not there, not there. What am I doing? In here. Duh. So I said 0 to 206, which is all these faces. If you go into options and say polygon indices, that's how I know which faces to select. So 0 to 206. I've just got that. I always forget where that is in the UI, so I just got a button up here that just does that, so that I can see the point indices or face indices. Okay, so anyway, once we have that selection, we can use that selection to also make a custom vertex map, because that's what the cloth object wants for its mix animation thing over here, so that we can just have this red part of the geometry simulate. Okay, so I guess let's do it all from scratch really quick. So if we go in here, go to asset, I'm already in there. If we're going to start off, it's going to look like this probably. And if you go to nodes, asset construction, we can make a nodes mesh that's just going to be empty. You double click that, and in here, I'm going to press C and make a plane. C again, and make a select, and then we're going to make a store selection also. So say boom, boom, and boom, boom. So then on our plane within here, we can make it however big we want. So let's make it maybe about, let's do 400. And let's look at faces. Let's give it some more segments. A little something so we can have the cloth have some movement to it. Okay, so that's good. So now let's get this selected. Let's look at the index. So let's maybe just do these first couple rows. So that's going to be from so yeah, let's do it this way so it's easier. So that's going to be from 0 to 137. So in here, I'm just going to say 0-137. And in the store selection, we'll just call this selection. And you see we got a little selection tag right here. You can turn that off, kill that. And so the easiest way to visualize this, I also kind of don't like this. I wish Maxon would do a little bit better with visualizing these. You have to make a couple materials, give them some different colors. Whoops. We'll do less offensive colors this time. And drop both of those on here. And do that. Okay, so now we've got our mesh and our selection. We can also come in here and create, because we're going to need this later, a vertex map. And in the vertex map, we're just going to drop this selection. I'm going to invert it because what I actually want is for this to be cloth, this to not be cloth. Come in here, let's make this cloth. In mix animation, we're going to go here, click with pins, and drop this vertex map. So if we just press play now, we're going to get that. Let's give ourselves some more time. Maybe 500 frames. Okay, so we get something like that. Press Control D, go here to the scene and turn the gravity to 0. So now if we press play, we just get nothing. All right, so then we can create a turbulence. Last time I just did that with a turbulence field. This time maybe I'll do a field force with a random field in it. Let's go to the display on that, increase this and decrease, not that axis, this one. So we can just look at our turbulence and kind of see it a little bit better. So let's increase the scale on that. And I'll increase the animation speed. And then in the field force, let's set an absolute velocity. And then let's turn off the work plane. And let's not set it, let's say add to velocity actually. And scale this up. Yeah, that's probably fine for what we're trying to do. Okay, so now we are going to select this object, make a mesh emitter. Restriction, we are going to just emit from that selection that we made. So here's another quick tip. So any of these dynamic objects that I wanted to make, normally, say like for this cloth, you got this tab here that says forces where you can say like, hey, don't affect this. I'm making this for something else. Don't be affected by it. For whatever reason, it's another thing that is really unintuitive. With the particles, they don't have that. So it's like, okay, well, I don't want my particles to be affected by this field force that I made to animate the cloth sim. I just want them to have like their own stuff. Because if I just start emitting particles right now, you can see that the particles are also being affected by this field force, which I don't want. So it's very easy. It's just unintuitive. You have to create another particle group, and then this needs to go in there. So let's just call this P exclude. So now the cloth sim is going to do its own thing, and the particles are not being affected. They're just going straight up. Okay. So now what I want to do is in the emitter, in the properties, the direction, it's going on the surface normal. But what I want to do is change it to axis, and I want to go on the local z-axis of the surface. So let's just watch what happens here. So we do that, and you see we're going like that, right? But the reason that this is important is, let's say if I took this mesh and I rotate it like that, like it's at some awkward angle. It's not pointing directly down the z-axis, the world space z-axis, but it's still, this is its local z-axis. That's the direction that we want the particles to flow. Local z, not world z. You can see that if we switch that to global, what happens? Now they're going on the global z-axis, not what we want. Okay, so let's all right, so we're back here. So now they're going local z. All right, so then we want to make the surface attract. We can drop that in here. So here's another difference between the X particles follow surface and the surface attract. The surface attract basically just works for any dynamic surface, versus you just picking a surface, like you dragging a surface into a box like this. For the X particles follow surface, it has this thing that says select geometry to attract towards. Again, this is unintuitive. I don't really get it. I don't, like, you click that and I'm not really sure how it works, honestly. But anyway, it'll just do it to this surface. And you can see that the particles are being attracted to the surface. Now let's crank up, make this a little bit more violent so that the particles can kind of start getting kicked off the surface. They're still, see, there we go. We can see some. Let's make it even higher. And let's in the random field, let's crank up the animation speed a lot, just so that we can, so that it throws the particles off the surface a little bit more. It's actually doing a pretty good job right off the bat. It's messing up my tutorial by actually working. But yeah, you can see some of the particles are getting thrown off the surface. You need to, you know what I should have done is, let's just make the turbulence and drop that in here. This is more active. Okay, so you can see that not all the particles are perfectly following the surface. So within the surface attract, one thing that you want to do is click apply object velocity. That's going to make things stick better. I mean, honestly, that's pretty much fixing it. And from there, if you're still having particles that are not following the surface, you can just crank these up. I've cranked these up into the thousands. So you just kind of keep going in terms of how much they're going to be attracted to the surface. Let's also add some zeros to the amount of particles we're emitting. Okay, so you can see we do lose some particles, but for the most part, most of the particles are following the surface. Let's make things look slightly more interesting. Let's make a noise and load a preset. And how about you? Cool. All right, so now let's kill off the particles that well, first off, within the surface attract, we need to go to the output and add this custom attribute, which is in range, so that then we're going to make a condition, and then within that we are going to make a kill. So in here, the property is going to be a custom property. The custom property is in range and equals 100 equals. Okay. So let's see what's going wrong now. Interesting. Let's just see. Okay, not equals. Interesting. Not equals. I think. Anyway, so yeah, pick one of those. Didn't I have it saying equals in the last one? Kill condition equals. That is so weird. Yeah, I don't want to troubleshoot this while you guys are watching, but yeah, this is annoying. So yeah, that's weird. In range, the kill thing, custom in range, and equals 100%. And that's what kills them in this example, but for this one, it's not equals. The opposite is what works, which is super weird. But whatever, there's only two choices, so yeah, there you go. Anyways, so that's pretty much it. And that's how you can get these particles to pretty perfectly follow the surface. And of course, now you can come in here and we can add, say, a turbulence. And particles are going to get lost more, but it's okay because that not equals thing is there. That is totally weird. So maybe not quite so strong. There we go, just a little bit. And then since you're killing a lot of particles because they're getting lost. Actually, I think that can be a little bit stronger. Yeah, maybe something like that. So then you can afford to just like have a lot more particles. So let's just crank this up maybe by many times. I guess that's another thing about this technique is that this is all pretty fast and we can have quite a lot of particles in here and things are still pretty nice and smooth. Hey, Midlet from the future here. Uh, quick little fix here. Order of operations matters with this. So the surface attract needs to come before the condition, which actually makes perfect sense. And things will work a lot better and even nicer. It's still, this whole thing is still weird. In the previous example, it was equals. In this one, it's not equals, but whatever. Uh, but in terms of just like the particles sticking to the surface and things kind of just working in a way that makes sense, make sure that the surface attractor is on top of the condition. Okay, bye for real this time.